Hi everyone! For this video, we're going to solve some problems that calculates vector length and identify the vector between 2 points. So let's start with our first example with vector A, where we have the x component of 5 and y component of 3. So from our previous video, the length of a vector is actually the hypotenuse of this right triangle. So using the Pythagorean theorem, so the length is equal to the square root of x component squared plus y component squared. So this is equal to the square root of 25 plus 9, where that is the square root of 34. So that is the length of vector A. Let's have another example. Let's say this is our vector. Let's call that vector B. And the components of vector B, we have 2 for x and negative 6 for y. And we're asked to calculate the length of vector B. Okay, so again, that's the square root of x squared plus y squared. So this is equal to the square root of 4 plus 36. So that is square root of 40. Let's simplify. Square root of 4 times 10 is 40. So square root of 4 is 2. And square root of 10. So this is the length of vector B. Next example is we're given 2 points, A and B, and we're asked to find the vector that runs through it, and also we're asked to find the length of vector AB. So let's start by plotting the points. So A is 2, 6. So that's 2. So this is A. B is negative 3, 7. Negative 3 and negative 7. Okay, and this is point B. So we have our vector AB. So this is the graph of vector AB that starts at point A and ends at point B. So one thing that we need to know here is that how far did the vector move vertically and horizontally. So from the graph, we can see that from 2, we move 5 units to negative 3. So that's negative 5. And from 6, we move vertically down to negative 7. So that's negative 13. Okay. So how do we represent that? So it's like vector AB is equal to the x component, so negative 3 minus 2, and the y component is negative 7 minus 6. So this is equal to negative 5, negative 13. So that's how we can interpret our vector AB. Okay. And now for the length, how do we calculate the length of vector AB? So knowing we have the x component of the vector and y component. So that is equal to the square root of negative 5 squared plus negative 13 squared. So this is equal to 25 plus 169. So this is equal to the square root of, and that's equal to square root of 194. Let's have another example. We have point C at negative 2, 5 and point D at 4, 3, and find the vector CD and the length of vector CD. So let's graph first point C. So it's negative 2, 5. This is C and D is 4, 3. 4, 3. Okay. So this is our vector CD, where it starts at point C and ends at point D. Also in vector, just want to point out that we have, for example, this vector. So this is what we call the tip or the initial point, and this is our tail or our final point. Okay. So to know the components of our vector CD, so we can see from the graph how it moves horizontally and vertically. So to find the vector between 2 points CD, we just need to subtract the coordinates of the initial point from the coordinates of the final point. So our final point is D. So our x coordinate, so that's 4 minus negative 2. And our y coordinates, the final coordinate of y is 3 minus the initial y is 5. Okay. So our vector CD is 6 and negative 2. We can also represent this using this way. And now let's calculate the length of vector CD. Okay, so this is CD length. Okay, so using Pythagorean theorem, that is the square root of 6 squared plus -2 squared. So that's the square root of 36 plus 4, so the square root of 40. Simplifying, 40 is 4 times 10. So the square root of 4 is 2. And 10 is just 10. So we keep that inside the square root. So therefore, the length of vector CD is equal to 2 square root of 10.